Hi, everyone. Welcome to our webinar this afternoon on Machine Learning Accelerates Performance Testing Analysis. Just before we get started, I want to make sure that we go over some housekeeping items. First, the webinar session is about 30 minutes long and it will be recorded, and we'll make sure we get the recording out to you after the event. And second, if you have any questions during the webinar, please feel free to pop them into the Q&A box at the bottom of your screen, and we'll try to get to as many as we can during the call. If we're unable to answer your question, we'll reach out personally after the webinar to follow up. As I said, my name is John Ellsworth. I'm the VP of Product Marketing at SmartBear, and I'm joined today by Emma Barbera, who's one of our fantastic sales engineers here at SmartBear. And to kick things off, I'd like to start by just talking a few minutes about SmartBear. Our tools are synonymous with quality across the software development lifecycle. We'll give you a little bit of a preview of those in a minute. We were founded in 2009 in Boston and have grown to have over 525 employees located in global offices around the world. We have presence in North America, in Europe, in Asia, and Australia. Over 6.5 million developers, testers, and operations professionals use our products to deliver bug-free software every day. They work in over 22,000 companies like Google and RBC and Vineyard Vines. And something we really keep close to our core as a business is our connection to the open source world. SmartBear is behind 3 popular open source initiatives, Cucumber, Swagger, and SoapUI. And we don't just offer tools for each of those initiatives, but we also support and integrate with other open source tools across our portfolio. Now, SmartBear, as I said, enables quality software engineering. And we cover really the entire software development lifecycle from design, where we have tools like Cucumber and HipTest and Swagger Hub. We also put Zephyr in there because it's a test management solution, so it's really helping you manage the process of testing, designing the process of testing. During creation of software, you can use tools like Service V and Collaborator for code review and Test Left to enable developers to do their own testing. In the testing world, we have API testing tools in SoapUI and LoadUI, API testing orchestration engine and test engine. We have Test Complete for functional testing and LoadNinja for load testing. And we have cross-browser testing and Bitbar, which are our browser and mobile device clouds for testing across multiple platforms and configurations. In the deploy phase, we don't have any tools directly, but we do integrate with all of the popular deployment engines from IBM and AWS and Microsoft Azure, et cetera. And after your software has been delivered, we have AlertSite, which is a tool that helps you monitor what's happening on your application. Now, our agenda today really is to show you how you can use real browser-based performance data aided by machine learning capabilities to avoid outages and slowdowns on your website or your web application. Now, in talking with customers, we found that many organizations struggle in this area, and they face challenges in trying to build performance testing to help them avoid these outages and slowdowns. What we want to share today is some of the ways to deal with those challenges using new approaches and machine learning to help get to the bottom of performance issues quickly. And we're going to take a look at some of the importance of performance testing and some trends in performance testing. We'll look at some of the obstacles that customers report facing in trying to get performance testing into place. We'll look at some approaches to addressing those challenges, and then we'll get into a demo of LoadNinja with its Sensei machine learning capabilities. And we'll have a Q&A session at the end. Now, if you're on this webinar, I imagine you'd agree that performance testing is crucial for anyone who's building software that's key to their business operations, which I imagine is everyone on the call anyway. There have been multiple studies to try to measure the impact of poor performance, and there are also lots of articles and blog posts that take a stab at summarizing those different metrics from across these different studies. And I'm referencing some of the statistics that have been pulled together by one of those articles here. You can see the link down at the bottom of the page. Now, the specifics of the impact of poor performance are going to be different from company to company, but but it's pretty well established at this point that abandon rates are high in the face of poor performance, and in the face of abandon rates, that has a significant impact on the top line revenue that a company is generating, or on customer satisfaction that a company is trying to deliver to customers who come onto their website. So the cost is real. It's well understood. And every year, especially in busy shopping seasons, you see examples of that. So, during Black Friday last year, the Friday after Thanksgiving, we saw cases where store systems went down. Like Macy's had an event where the store system went down and they couldn't handle transactions. Amazon, even one of the more mature software organizations in the world, had slowdowns and outages on Prime Day just this July. And it's very likely that in the next few weeks, somebody else will be in the spotlight. The question is really less about whether someone will be, but rather who. And hopefully it won't be anybody here. So performance testing is important, but of course it doesn't happen in a vacuum. What's happening in software development plays a big role in shaping performance testing. So let's take a look at what we see at SmartBear in the software development world. First, I think it's well understood, and I would imagine that you see the same thing, that the shift from waterfall methodologies to Agile and CI/CD approaches really has the effect of compressing development and test cycles. So developing, releasing, gathering feedback, and analyzing usage, and iterating into new releases is all happening much more quickly than it used to. Way back in the day, you might have annual or semi-annual releases of products, and nowadays it's much more common for products to be released either on a quarterly basis or a monthly basis, or even a continuous basis, particularly for websites. This really puts time pressure on all forms of testing, from functional testing, whether it's on the API or UI side, to load and performance testing. And really, one of the things that's happening there is it's really forcing significant changes in the way this testing is done. So first, automation is much more important in this model than it has been in the past, strictly because of the advantages of performance and throughput that you get with automation. Second, unit testing by developers is really crucial. So having developers test left, whether it's functional testing or test left on performance testing, they're getting into much more of a testing role than they have in the past to keep bugs from getting into the source code system in the first place. What we're also hearing is that this compression is really forcing customers to rethink how they think about performance testing. So performance testing teams really can't sit in the middle of a release process anymore. Rather, their role is often shifting to enabling developers to do performance testing efficiently and effectively with automation, scripting, and tools, while they continue to do periodic performance tests against releases. But those testing cycles just are too long, and they can't sit in the middle of the release cycle in some cases anymore. So what's that creating in terms of significant challenges for performance testing? Well, first, there are time and cost challenges that are being created. Performance testing isn't easy, it's hard. It takes time to create the tests, it takes the scripts, it takes time to update the scripts and the tests as the app changes. It's expensive to build a performance testing center of excellence. It's expensive to maintain that environment. So it's very time intensive and very expensive. And that's not the primary focus of our webinar today, but it's important as context for the next set of items. And that is that analyzing the results is also quite expensive and quite difficult. And there are a number of different factors there. First is getting the data that we need to be able to understand what's happening in the product is a challenge. Are we getting the right data, the data that we need to identify whether there's an issue or where that issue lands? Is the timing data granular enough so that we can actually see where in an application or website the problem lies? And if we're getting all that data, how are we coping with the data? Coping from a volume perspective, because we just talked about a lot of potential data points, and all of that has to be analyzed and understood by people who know how to do that work. Is the data the most accurate that we can get, or is it just sort of directionally correct as to whether a performance issue might take place? Is your test environment, really like your production environment, or is it somewhat different? Are the performance test users, the automated test users, are those really like a real test user in the tools and browsers and platforms that they're running on, or are they just approximations? Now, if you're getting all the right data, as I said, do you have the right people, the right tools, the right skills to correctly analyze and interpret that data? And again, do you have the capacity to cut through all of that volume of data to quickly identify the places that your developers should focus on to solve whatever issues are being surfaced in your performance test? So some of the approaches that we can use in addressing these challenges are shown here. On the time and cost side, I'll just move quickly through this because, again, it's not really the focus of our webinar today. But first, automation, again, is crucial. Automating your performance tests with scripts is something that really is necessary, and more to the point, doing it by driving the browser with capture and playback, as opposed to having to do script programming, manual script programming, is a real advantage to driving rapid script creation and maintenance. Testing components as opposed to the whole application is also a key capability, and doing that in the context of shifting that performance testing left to developers is also a great way to do that, because it enables the developers to focus on the modules that they're changing and adjacent modules, related modules that may be affected by the work that they're doing, as opposed to having to test the whole application. And then all of these sort of feed into embracing a continuous performance testing methodology as part of an overall release pipeline. And certainly the more mature organizations are going to look to do this if they're not already. So that's on the time and cost side. If we look now to analyzing results, things to consider here. The first thing we would say is that make sure that you're getting good data. Make sure it's deep enough and includes the key elements that you need to do the analysis, like UI navigation timing, capturing the network operation timings within the site or the application, whether those are API calls or time to download content and response to actions, or even take a look at things like the size of the downloads, and because those can affect, those can be surprisingly large or unexpectedly large, and they can affect obviously the time required to download. Do that for every step across the different load points in your performance test, of course, as well, so that you can get a clear picture of how that data changes as your load increases or over time. And then finally, make sure it's accurate. Make sure your users aren't using emulators, so make sure that the data you're getting is captured using real browsers and representative configurations, and so that your test data can reflect what's happening in the real world. Now, if you're getting good data and it's at the right level of granularity, you're probably going to have a lot of metrics to parse through, so you're going to need tools to help you make sense of it all. Reporting and analytics tools to help you, aggregate the data and visualize trends within the data and where issues might exist can certainly help. But remember, somebody has to go create those reports and analytics beyond whatever package or canned tools that might come with your platform that you're using for performance testing. And you may still have some struggle to identify what the root cause of specific issues might be. And that's really where machine learning can start to help. With machine learning, you can have algorithms crawl through your data and do a lot of that work that a team or an individual might need to do today to really dig into the data and understand what's happening. You'll have to train the machine learning and the algorithms, but once you've done that, you should have a system that can really help pinpoint specifically where the problems are that developers or QA engineers need to dig into in order to get what they need. And that's really what we wanted to show you today, how machine learning can help transform the process of understanding your performance test data. And we're going to do that in the context of LoadNinja, which is what we believe is the most realistic performance testing platform on the web. LoadNinja has a number of key differentiators relative to alternatives out there. First, from a script creation perspective, LoadNinja makes things quite easy. So instead of scripting manually and doing all the dynamic correlation manually and hand coding, LoadNinja offers recording and playback that allows you to create your scripts in minutes and not hours. It's also more accurate in the sense that it's running in the cloud. It's using real browsers, tens of thousands of browsers to generate the level of load data that you need. But actually load data that's not done with emulators, but rather with real browsers, so that the data that you get back will be much more representative of what users will use when they're accessing your web app or your website. And it also offers predefined analytics and visualizations to help you analyze what's happening in your performance testing in real time. And with the latest release of LoadNinja, we've introduced machine learning and AI to help you go through the process of doing that analysis. And with that, I'd like to turn things over to Emma to give us a demonstration. Emma?
All right, perfect. Thank you for that introduction. So let me just get my LoadNinja shared over for you guys to see here. What we're looking at now, we're going to take a look. We'll walk through a couple of things here today in the demonstration. We're going to walk through how we can record a test in LoadNinja, and then we're really going to spend the majority of our time here diving into the results and what those look like and how we can analyze those to get the most information out of those results. So what we're up on here is our dashboard. LoadNinja is our SmartBear's cloud-based platform for load testing and performance testing of websites and web applications. So it's here to help developers and QA teams and performance engineers check if their web servers sustain a massive load and if the servers are robust and scalable. What you may or may not be familiar with is the fact that traditional load testing tools create performance test scripts for your websites and web applications by recording the HTTPS protocol traffic. This is something that LoadNinja does not do because we're actually allowing you to test your website and web apps on real browsers in the cloud, and we're not having you, perform any dynamic correlation or anything like that during the process. So it really streamlines how you can get started and how easy it is to walk through the creation here. So we'll just get started with a quick recording here. Right. So once you create a project, you can go ahead and start recording. All you'll need is the URL of the website that you'd like to test. So I'm just going to grab the URL from our sample pet store, click the record button, and then we'll go ahead and paste that URL in the recording pop-up here, select the resolution that we'd like to record on, and then we can instantly start our recording. You'll notice the steps will get recorded on the left-hand side, and on the right-hand side, you'll notice our embedded browser where we're going to be able to interact with our website and record the transactions that we'd like our user to go through during the performance test. So I'm going to start with a simple logging in, navigating around in our website, and then logging out. Once I've recorded my test case, you'll see that LoadNinja populates the steps into groups, which we actually call steps. And then these will be important when we actually start to take a look at the results. So what I'm going to do is just show you how easy it is to go ahead and play this test back. And then we're going to jump into taking a look at the results because that is mainly why we're here today. So as you can see, once you go through that recording process, there's no added steps in order to be able to play this test back and use that in a load test scenario. So apart from other tools that are requiring you to spend a lot of time with that dynamic correlation, because LoadNinja is running on real browsers, we're actually able to do this, instantly with no dynamic correlation required. So that's going to save you a lot of time just really in the creation process, and along with the load scenario and then the analysis as well. So that's really what our recorder looks like. Looks like we have a question: can LoadNinja be deployed on a private cloud? So at this time, we are just using our load generators on the LoadNinja side. So this is accessible from a website, and you are able to test internal applications, but the load generators will have to come from the LoadNinja side. So right now we're just going to reference some results that were previously done, just so that we can save time in running our load test today. So what I want to start with here is the virtual user debugger. So in this area, you're going to be able to come and actually see all of the errors that have occurred. In this test case that we ran, we actually didn't have any errors, so you won't see any listed here. But in the case that we had any types of errors, such as we have different types of validations that you can apply, you'll see those listed here. Any types of object recognition errors or things like that, you'll notice in the virtual user debugger. The charts is really, I think, what's a great feature of LoadNinja. So a lot of what John was talking about earlier is not only the ability to run these load tests, but the ability to get back results that you can actually take a look at and analyze. We want to make sure that the results that we're providing for you in LoadNinja actually mean something for your end users. So what you can see are these charts. The first chart is the script and step durations chart. So this is really going to show you how long it's actually taking to run this test case. So for the durations, it's going to be the average duration of each script, which you can filter here on the left. And you'll actually be able to see how long each one of those particular scripts is taking. And you can also narrow that down all the way into particular steps here. So if you wanted to break that down into one individual, maybe just the login page or the search results, you'll be able to narrow this down to a particular step. The navigation timings are going to be the results that you see on the first chart, but we're going to be giving you the redirect time, the DNS time, the connect time, and this is really just going to focus on the network timings as the virtual user is loading the page in its browser. And we focus on this because timings notably affect the user experience, so we want to make sure that you keep these values as low as possible. So once you've taken a look at these charts, we can really dive into how exactly we're getting these results from the network analytics tab here. And so this is really where machine learning comes into things. So you can go into a particular step, choose the Analyze button, and then we'll go ahead and do the work for you here on our end. So what you see here is, as the virtual users are getting added to our application, that's going to show on this chart here. The Network Analytics tab is focusing on the network statistics of your test steps and analyzing the steps by using a built-in AI. So the statistics that you're going to see in this chart include the time spent making requests and loading web resources, the number of bytes received, and other data. And so you're going to notice this in waterfall charts here, and then you can also choose the pie chart view as well. So as you cycle through these options here, these are the iteration that you're on. So this had 15 iterations in this load test, and I can see actually for each individual step, all the various pieces that were actually loading on my page here. Just gonna find one that has more information to look at. So as you can see, each individual item that was loaded on the page is then broken down here for you. So if you're seeing an extremely large time on, say, the search results of your web page, you can actually come into this virtual assistant, and then we'll analyze the results for you using the identify anomalies button. So say I decided that this page in particular seemed to be having some issues based on the charts that I looked at on the first page. I'll use the identify anomalies button, click analyze, and then the sensei is actually going to it's going to view all the details for you from your iterations, and then it's going to give you back some advice. So with all the information that the sensei has, it's noticed that there seems to be an issue with a connection point in the back end. It's going to let you know exactly what point this error seemed to occur, and then it's going to give you some suggestions in how you can mitigate this problem. You can see we have another issue down here with our bandwidth. And so again, it's going to provide you with, information and suggestions moving forward and what might actually be going on with your application. So this is for each individual step of your test cases based on, in this case, 15 different iterations of the test. And that way the sensei is able to, really hone in on a specific point in your test when you're running into these issues. And this is something that if you were having to sit here, to combing through all of this data yourself, it's really going to take you a lot longer than it's going to take this tool to just analyze all of that data for you. So that's really our goal here, is to come and give you a way to, really visualize what's going on in your application, step by step of your load test, and to get back all of the data for each of the resources and whatnot. So we do have more detailed information on, what all of the individual components of this network analytics tab mean. So please feel free to take a look at our documentation if you have specific questions on any of the terminology that you're seeing here in the Sensei. We will take 1 or 2 minutes here to answer a couple questions, and then we do have to hop off here. So let's see if we can get any questions answered here. So it looks like we have a question about hooking up LoadNinja to a database. At this time, to run data-driven test cases, we have the ability to use a CSV or a text file to go ahead and data drive those test cases. So if you want to make them more robust, then yes, you can use a CSV or a text file. At this time, we're not yet supporting databases such as SQL. I have a question here. Do we need to train the AI? So the answer to this question is yes. Once you see what the sensei suggests, you'll have to take a look on your end to see if that actually was, a problem that you were encountering. And then you can tell the LoadNinja tool that, yes, that was a correct assumption. And then it can learn from, diagnosing those correct issues as we go. So hopefully that answers the training of the AI, and that kind of covers the next question about how does Sensei know what to recommend. So it's going to have to learn as you go, but you'll just have to, take a look at what suggestions it has made and then see if they are, correct for you. And then you'll be able to tell it that, and then it will know in the future how to approach those situations. It looks like we do have a couple questions here that we're not going to have time to answer live today, but I know that we'll be providing you guys with the option to go ahead and, book a session with us, so where we can specifically focus on your questions, or we can always reach out to you guys afterwards and get those questions answered as well. So I am going to have to close the demo off for today, but like I said, if you guys, are super interested in this, please reach out to us and we can have a full demonstration of the tool, because there are a lot of aspects that we're unable to, cover all of them.
We have already answered a bunch of the questions. As we said, we won't really have time to answer others, but we will certainly commit to following up and giving you additional answers as we go. I'm going to close with a poll here. If you would like to talk to somebody about LoadNinja, just let us know and we will reach out. Otherwise, we really appreciate your time today and hope that you found the material is helpful.